Hi all, we studied modeling of mechanical systems in last class. Now we can do some problems. Question is, write the differential equations governing the mechanical system shown in figure and determine the transfer function x of s by f of s. Mechanical system is given. The method is, here we have to consider masses m1 and m2 as two nodes. Let the corresponding displacement be x1 and x. First, what we have to do is we have to draw the free body diagram of mass m1. Draw all the forces acting at this node. The force is applied to the second node. So here, opposing forces are inertia force, damping force, restoring force due to K1. Also, these two elements B and K, they are connected in between two nodes. So the forces acting at node at the first node, they are Fm1, Fk1, Fb, Fk1 and Fk. These two elements are connected between two nodes. So we have to take these two elements while writing the equation for second node also. So equation is m1 into d square x1 by dt square plus b1 dx1 by dt plus b into b connected between two nodes. So x1 minus x1 minus x plus k1 x1 plus k into x1 minus x1 minus x equal to 0. In this way you have to write the equation. And considering the second node M2, here the applied force is acting in this direction, or other opposite forces are acting on the opposite direction. Write the equation M2 into d square x by dt square plus B2 dx by dt plus B. This B is connected between two nodes, so d by dt of x second node, so x minus x1 plus k into x minus x1, that's equal to applied force f of t. F of t is connected to the second node. So these two are the differential equations. So write the differential equation, that is the first part. So this equation and this equation. Now it is asked to find the transfer function x of s by f of s. X of s by f of s. So for that, what we have to do is we have to take Laplace transform of these two equations. In order to find transfer function, we have to take Laplace transform, because transfer function is the ratio of, what is transfer function? Transfer function is the ratio of Laplace transform of the output variable to the Laplace transform of the input variable, assuming all initial conditions as 0. So take the Laplace transform of this equation. Again, you have to apply the differentiation theorem. So m1 s square x1 of s. m1 s square x1 of s. Similarly, right, here also you have to apply differentiation theorem. Here also you have to apply differentiation, and here also. So b1 s into x1 of s plus b is x1 of s minus x of s plus k1 x1 of s plus k into x1 of s minus x of s. Take the Laplace transform and find x1 of s is equal to. Similarly, for the second equation also take the Laplace transform. Here there is x1 of s. We want the ratio of x of s by f of s, but here there is one x1 of s in this equation. Substitute the value for x1 of s from this equation. For this x1 of s, substitute this expression. Then you have to simplify. Then finally you will get the transfer function as this. So the result is the differential equations, these two equations, and the transfer function is this, x of s by f of s. That is the answer. Second example, find the transfer function of the system shown. Here two masses, so two nodes M1 and M2. Displacements are Y1 and Y2. Force is applied at first node. So draw the free body diagram. Force is applied at this particular node. All other forces are acting on the opposite side. So write the equation. Here again, this element K2 is connected between two nodes. Therefore, K2 Y1 minus Y2. M1 into T square Y1 by dt square. This M1 d square y1 by dt square plus d into dy1 by dt plus k1 y1 plus k2 into y1 minus y2 equal to f of t. And take the Laplace transform because we want to find the transfer function. So take the Laplace transform. Similarly, for the second node also, draw the free body diagram. Write the equation here k2 into y2 minus y1 m2 d square y2 by dt square plus k2 into y2 minus y1 is equal to 0. Take the Laplace transform. Y1 of s equal to y2 of s. Here we are taking the transformation as y2 of s by f of s. So from this equation, write y1 of s is equal to and substitute this in this equation. Y1 of s. Then simplify. Finally, you will get the transfer function y2 of s by f of s is equal to k2 divided by this expression. That's the answer. So in order to find the transfer function, we have to take the Laplace transform. First, we have to write the differential equation, then take the Laplace transform, then find the transfer function. And we can do some problems in force voltage and force current analogies. Consider the question is write the differential equation governing the mechanical system shown in figure. Draw the force voltage and force current electrical analogous circuit. So this is the mechanical system given. So M1 displacement is x1, M2 displacement is x2, K1 and B12 are connected in between these two nodes. M1 here this B1 frictional force B1. Here it is given, here there is no frictional force. If it is given, you have to take it, otherwise take it as 0. So draw the free body diagram. Force is applied at this particular node, so force is there, all other forces acting on opposite direction. Write the equation M1 d square x1 by dt square plus b1 dx1 by dt plus b12. It is connected between two nodes, therefore x1 minus x2 plus k1 into x1 minus x2, that's equal to f of t. That is one equation. Similarly, consider the second node. Write the corresponding equation. So these two are the differential equations. Then in this particular program, it is asked to find the it is asked to draw the force voltage and force current electrical analogous circuit. No need to find the transfer function. In that case, there is no need to take a Laplace transform. If you want to find the transfer function, then you have to take the Laplace transform. Otherwise, here we have to draw the force voltage and force current electrical analogous circuit. So there is no need to find the Laplace transform. So here this step you have to remember. Here you have to replace displacement by velocity. So d square x by dt square is equal to dv by dt, dx by dt is equal to v, and x is equal to integral v dt, velocity. So substitute these values in this equation. So you will get this equation. First you have to substitute in this equation and then in this equation. So these two equations. For force voltage analogous electrical circuit, the given mechanical system has two nodes. Hence, the force voltage analogous electrical circuit will have two meshes. The force applied to mass M1 is represented by the voltage source in first mesh. Elements M1, B1, K1 and B12 are connected to first node. Hence they are represented by analogous elements. We have to take the analogous values for these elements. Hence they are represented by analogous elements in mesh 1, forming a closed path. The elements K1, B12, M2, K2 and B2 are connected to second node. Hence they are represented by analogous elements in mesh 2, forming a closed path. The elements K1 and B12 are common between node 1 and 2 in the mechanical system, and so they are represented by analogous elements as common elements between two meshes. So we can see that K1 the analogous value is C1 and B12 the analogous value is R12. So R12 and C1 are the common elements between two meshes. So take the analogous values of all these elements and draw the two meshes. So this will be the force voltage analogous electrical circuit of the given mechanical system. We can write the equations for two meshes. That is L1 di1 by dt plus R1 I1 plus R12 I1 minus I2 plus 1 by C1 integral I1 minus I2 dt is equal to the applied voltage ET by using Kirchhoff's voltage law. Similarly, for the second mesh, we can write this equation. We can see that these two equations are similar to the differential equations for the mechanical system. These two equations, they are similar. In this way, we can draw the analogous circuit. This is force voltage analogous electrical circuit. Similarly, we can draw the force current analogous electrical circuit. Here, in the given mechanical system, as in the previous case, two nodes masses. So, in force current analogous electrical circuit, there will be two nodes, and the force is applied. The force applied to mass M1. It is represented by the current source in force current analogous electrical circuit. The force applied to mass M1 is represented by a current source connected to node 1 in analogous electrical circuits. The elements M1, B1, K1 and B12 are connected to first node. Hence, they are represented by the analogous elements in node 1 in analogous electrical circuit. Similarly, elements K1, B12, M2, K2 and B2 are connected to second node, and hence they are represented by analogous elements in node 2 in the analogous electrical circuit. And again, this K1 and B12 are common between two nodes, so they are represented like this. So K1, the analogous value is L1, and B12 analogous values is R12. So they are connected like this between two nodes. All other the elements for the first mesh, first node is connected to the first node, and these elements are connected to second node. So this is the force current analogous electrical circuit. We have to write the analogous values from the table. Check which elements are common. Draw like that. And nodal equations by using Kirchhoff's current law can be written for this circuit, and you will get these two equations, and it is observed that these two equations are similar to the differential equations of the given mechanical system. So this is force current analogous circuit. Thank you.